In this tutorial, we're going to see how to make a simulation. There are four components. This is a connect rod, this is a crankshaft, here is a sleeve, and the piston. We're going to start. Those are imported as dumb bodies, and we're going to start to create assembly first. First, we're going to make a new assembly. We want to make assembly which has the same unit as our components, right? So let's check the components unit. So we can go to File, go to Property, and then go to Display Part. You can see it is a millimeter. So we're going to create assembly, use a millimeter as well. Get started. File, New, and Model. We're going to use assembly as our template. This assembly, okay, and we're going to use say lab 11 assembly with my initial, and we're going to put it in document and enter. So we're going to reach 11 motion simulation. Hit OK. Hit OK. Okay. Now we're going to put all of them and hit OK. Right. So all four components are being put here, and if we look at the part assembly navigator, then all of them included. Let me save this for now. Okay. You can see this is my sleeve. I would like to say go to Assembly tab, and I would like to create the assembly constraints. I want to make this one to be fixed. This is my sleeve, right? So cylinder sleeve is the one I selected. I would like to make the fixed, right? So select object. Okay. You can see a symbol is being displayed here. Hit OK. All right. So once I made this fixed, then I will not be able to move my components anymore. Right. So you can see I can move this one. I can move. Oops. I can move. Hit apply. I can move this one up and down, back and forth, right, and so on. Okay. I can also move components. Select object. I would like move. Right. Once I select, I highlight this specify orientation. Then the handle is given. Right. So I can rotate. Okay. I can move back and forth and so on. Okay. Cancel this one. Hit OK. All right. I'm going to put everything in order. Just use constraints to build constraints. First constraint is this one, right? So fix the sleeve. Okay. Now I'm going to create this again. So I use touch align. Touch align can build the constraints, most of them, right? So we can also use a concentric and so on. Okay, so I'm going to use constraint. Okay, use this touch align. First, I'm going to put this rod and the piston together. Okay, so what I'm going to do, I'm going to use this. Use quick select from the list. I would like to choose the center line of this, okay, of the rod, this center line with the small one, okay, and then choose the center line of this hole. Center line of this hole, you can see we can choose different lines, choose different objects. We would like to choose center line, and you can see it's aligned. Okay, so once we do this, then hit apply. Then you can see this constraint is being displayed in the assembly navigator under constraints. Once we do this, we're going to make this surface, the surface of this aligned with the surface of my piston. Okay, you can choose different surfaces, and this surface is what we want, and hit apply. Now the second is being put here. This two make the constraint between the piston and my rod. Once I have this, and if I try to move my components, you can see is isometric view. If I try to move these components, what will happen? You see, my rod is rotating above this hole because this two center lines being aligned to each other, right? So let me put it here, isometric view. Now I'm going to put this hole with this shaft. So what I'm going to do, assembly constraint, use the same type of touch and align. This time I'm going to use the center line of this hole. Okay, center, make sure you choose the correct object, and then use the center line of this shaft. Hit apply. Now you can see this is being created and listed in Assembly Navigator. Okay. Now, what's next? The position in the shaft in X direction, right? So what I'm going to do, I'm going to, let's say clear, right? Clear, no one being selected. Okay, so I'm going to say this surface, inner surface, and the surface of this align to each other, hit apply. Now you can see this allow us to create the relationship between these two components. All right, I'm going to save my files so far, and then we can put this one in here to make sure the shaft of this shaft mate with or constrained with this hole. Let me do this. So the center line of my shaft will align with the center line of my hole, which is this one, and hit apply. It's been given here. All right. Okay. Now, what I'm going to do, I'm going to make this surface aligned with this surface and hit apply. Now it's being put here. Let me check. First, to save it, move my components. Let's say I want to move my piston and rotate it, right? Oh, rotate. Okay, so and no other degree of freedom is being available. Okay, and let me rotate a little bit more. All right, okay. Now you can see I almost get everything in position, except the piston should be put inside the cylinder. Then what we can do, we can still use this one to use the center of my piston aligned with the center of my cylinder, and then hit OK. Now you can see this piston and the sleeve is related using this align constraint. Let me save it and then put here what's happening. Let me see. We try to move this, use dynamic. You can see I will be able to rotate my crankshaft to drive the piston up and down. Right, so hit OK. Save my file. Now, how many degree of freedom for each component? Let's say show the degree of freedom. So first, let's check this one. It says there are no degree of freedom for my sleeve, right? So because it's fixed, because of this one. And all the relations, okay, so show the degree of freedom for this crankshaft. You can see one rotational degree of freedom. Okay, so refresh. Let's check this piston. Move up and down 1 degree freedom, right? One translational degree of freedom for the piston. Let's refresh. How about this one? It also has 1 degree freedom, rotational degree freedom. Okay, rotational degree freedom in YZ plane. Okay, all right. So that's for the assembly. Now we are ready to create our motion simulation. So again, make sure you save your file. Okay. So now, what we're going to do, we're going to go to application, and this is motion simulation. Click it, and then you can see we would like to create a new simulation. Hit OK. All right, so we're going to just use the kinematic because we're not interested in the force and so on at this moment. Hit OK. You can see, make sure start join the wizard upon new simulation. Hit OK. All right, so because there are some constraints and components being put here, so we can see some joint has been created automatically. You can see the links 1, 2, 3, 4, 5, 1, 2, 3, 4, sorry, 1, 2, 3, 4, and the sleeve is being fixed. Okay, it's considered at the base. So this really is a 4-bar linkage, right? So the joints is being created, right? So we would like to see, we would like to make sure the joint, Revolute joint, between the sleeve and the crankshaft will be the driver, right? So let's look at it here. So let's see the information. So you can see this is a Revolute joint between rotationary, okay, rotationary. This joint type cylindric. All right. So this it's between the piston and the sleeve. So this is not what we want. We would like to see another one to see if we can find. This is a crankshaft and a sleeve. Okay, so Revolute. Okay, so this, you might make sure it is between, okay, link name is a crankshaft and a sleeve. So, and its type is Revolute. So this is the one we would like to use as a motor. So motor. Okay, save it, save my file. Once I have this one, once I find this one, okay, see, it's highlighted, right? This being highlighted, okay? So you can also find it by click here and show in the motion navigator. Okay, once we have it, we're going to create the motor, okay, the driver. Hit OK. You can see I've selected it and then select drive. Oh, and in another way, you don't select anything, the driver, and it asks you to select which one you are going to select, the motor. Okay, and the velocity 100, polynomial, make sure you use polynomial. Okay, so velocity 100, I'm just going to use default and hit OK. Then you will be able to see the driver. Okay, the driver. Okay, you can also reverse direction. You can also reverse direction by put negative value here. Okay, negative value. Okay, then it will be rotating in a different way. Okay, so this indicating the a positive direction. Okay, so I'm going to put here. Once we're done, we can solve the solution. Okay, create a solution. All right, and gravity, we put just use the default. The gravity is going to be in Z direction, right? So okay, it's already shown here. If your gravity direction is not correct, you just need to choose this one. Okay, hit OK. Check it. So you can see the time is 5 seconds and the step is 50. Okay, so hit OK. Now let's solve it. You can either select right click and solve it, or you can select it and then solve it. Okay, now you can see I got my results. Then we can see the animation. Okay, Here's the results, time. Okay, animation. Okay, this is what we have. Okay, and then now stop. Okay, you can play it. You can also rampa rate, right? So you can also play back, okay, and so on. Once you're done, then you can return to the model. Okay, return to the model, and then we can also see if we have other